Howdy, it's tubalcain again, and this is the third in a series of videos that I've made about my little RHODES shaper. Now, in the other videos, it was more of an introductory and how I acquired the machine and all of that. But in this particular video, I want to talk about the mechanism inside of the case here, and it's called the Whitworth Quick Return Mechanism. And I've made a teaching aid to show you how it works. And the idea with the quick return is that since the shaper is a relatively inefficient piece of machinery, cutting what we would have thought of only as half of the time on the forward stroke, but in fact it cuts about 60 or 70% of the time, because the return when it is not cutting is called a Whitworth Quick Return. And the mechanism for that is quite ingenious, but is a little bit difficult to understand, especially to the casual observer. There's a large gear here, that's called the bowl gear, and it is driven by the smaller pinion gear, which comes from the motor. And that gears it way down. And then we have a mechanism here, we have a Scotch yoke and the quick return mechanism, and it pivots off of this point down here at the bottom. And at the top it connects with the ram. Now I'm going to turn it on here in a minute, and I've got it set for a real long stroke so that you can possibly more easily understand that it's moving faster when it's returning than when it's going forward. If the stroke is set real slow, it's not so evident. Or real short, rather. It's not so evident. Can you see that the return is faster than the forward cutting stroke? This mechanism also allows us to change the length of the stroke. And the maximum on this little machine is 7 inches, but you could set it for as short as a ½ inch, I suppose. And also you can position the stroke where you want it according to the size of the work. So you could have the tool moving out here or in here. And that's done with this binding lever on the top. But the length of the stroke, and there's even numbers here to indicate the setting of the stroke, by loosening this square nut here and sliding this up up and down into different positions. Now some machines will have that adjustment on the other side. They're not all the same. There's really only two mechanisms that are employed in metalworking shapers. One, which I'm not going to discuss, is a hydraulic shaper, and that's nothing more than a hydraulic cylinder that is moving it back and forth. But this is called the crank type of mechanism. So, and that's what this video is concerned with. Let's take another look at this speed differential here from this side. And that is, when I turn it on, notice that it is moving more slowly going forward and quickly in the return, or the non-cutting stroke. And now let's go down to my other shop and I will show you how this works. I've made a teaching aid, and I want to talk a little bit about the great man himself, Joseph Whitworth, who invented this mechanism. The Whitworth Quick Return Mechanism actually employs a Scotch yoke, and this is a Scotch yoke, and you've seen this in some of my videos, and I've used that on different engines. And a Scotch yoke simply converts rotary motion to reciprocating motion. And if you want to see more about that and want to see these engines run, I do have two videos, one called Over and Under Stirling Engine Hot Air by tubalcain, and the other one's Hot Air Stirling Engine number 2 Scotch Yoke tubalcain, where I discuss that. This is the Whitworth Quick Return Mechanism, and I'll be talking more about that here in just a few minutes, but I want to talk about Mr. Whitworth first. You know, we Americans are prideful and boastful, and we try to take credit for all of the technical innovations that have been done in the world. The U.S. history books make very little mention of what went on abroad as far as inventions are concerned. But Sir Joseph Whitworth was born in 1803 and died in 1887. He was an English engineer, and he was responsible for many innovations, and among them the Whitworth Quick Return Mechanism, but also he had worked with Henry Maudslay, who was the inventor of the screw cutting lathe. And he worked for and I can't even pronounce that name, but that's an ornamental lathe that many of you will be familiar with, that they made over in Europe, that did fantastic woodworking, and you can find some information on YouTube about that. And he also helped with the manufacture of Charles Babbage's calculating machine, the differential or the difference engine, which was one of the first computers. Whitworth popularized a method of producing accurate flat surfaces for surface plates. He invented the Whitworth rifle to replace the old Enfield. And he designed a large rifled breech loading gun for military use. And in 1884 he devised a standard for screw threads with a fixed thread angle of 55 degrees and having a standard pitch for a given diameter. And on this little Starrett center gauge here, 55 degree, you can see where it says it's the Whitworth standard. And some of you British guys that work on motorcycles are familiar with the Whitworth wrenches and the Whitworth threads. In getting ready for this video, I wanted to make the mechanism, so I made a prototype of the teaching aid. This only took 45 minutes, and it was made with pieces I already had in the shop, such as this slotted bar here, so I didn't have to really do much machining other than this slide block right here. But this was to prove to myself that I could make the teaching aid successfully and help me with some of the dimensions. So often I do that. I make a prototype. Sometimes they're totally out of wood or plastic, but this is a wheel out of a Helen Bowell projector. You've seen that on some of my engines. And in a moment, the real mechanism will be shown. Okie doke. We're finally down to the business at hand, and this is the Whitworth Quick Return Mechanism. And I have constructed here just a few things to show you the basic parts or the basic mechanism of the shaper. And what we have here is a large gear, and that's called the bull gear, and then there's a smaller gear, which would be a pinion gear, and that is the driven gear. And in fact, I wanted to use a slightly smaller one like that, but this one was in too bad a condition to use. It didn't mesh properly, so I've got a little bit larger gear than what I want. But on different shapers, you may see this gear in different positions. It may be up here or maybe down here. And this is the rocker arm, and there's the pivot point, and I showed that to you out in the garage at the actual machine. This is the ram, and it's held here by some ways. And there's the tool holder and the cutting tool and the work and the vise. Now I'm going to crank this, but this also is going to be run later by my electric drill a little bit faster. So here we have again the rocker arm and the slide block that goes up and down, and that little portion of it actually is the Scotch yoke that I talked about a little bit earlier. This is just a counterweight here to overcome the weight of this tool holder here. Now it's important to remember that in most shapers that this is big gear, the bull gear, is going to run clockwise. Now I have watched some videos on YouTube where the person had the motor running backwards, and in fact it was running this way. And that is incorrect, because then the fast motion is going to be forward when you're cutting. So it needs to run like this so that this is clockwise. Now of course we can adjust the distance here. It's way too long of a stroke for this size work, but you get the idea here of what I'm doing. It cuts only on the forward motion. Also I have made a homemade protractor here and may not be showing up too well on camera. I would have liked to use this type of protractor. That's one that I had in college that really is a neat one, but that isn't going to fit in there. So I use this to make this protractor that's on here in brown paper. I have this little pink sticker on here just to act as a marker. Now watch that go around. Now at the end of the stroke, the return stroke, which is right about here, I have placed the marker. Now watch the ram move, and I'm going to stop it when it's at the end of the forward or cutting stroke. That's the end of the stroke, and we've gone about 210 or 220 degrees. Remember that now. 220 degrees, approximately. Now as I continue from the 220, as it goes into the return, there's the end of the return, I have basically about 140 degrees. So the cutting stroke takes quite a few more degrees, 220 degrees, than what the return stroke is. So let's watch this again now. So the return stroke, starting right here, since it covers fewer degrees, is happening faster. It's very quick. But we have to cover a whole 220 degrees in order to have the cutting stroke. So it takes longer. And that is the principle of the Whitworth quick return mechanism. Now, because my mechanism is rather crude and parts of it are made in wood, there is considerable backlash at the end of the stroke. In other words, you can see that I'm moving several degrees here, 10 or more degrees, and nothing's happening. Same thing on the other end, backlash, and that'll be true on a commercially made machine as well, but it probably won't be as much backlash, but there is always backlash. And remember that in any reciprocating motion, whether it be an engine or a shape or whatever, no matter how fast it's moving, the mechanism is still coming to a stop momentarily at the end. In other words, a piston in a car, even at 10,000 RPM, is stopping at the end of the stroke before it can reverse. But we do have lost motion or backlash here, and I'm kind of ignoring that when I talk about degrees here. The rocker arm on its pivot here is moving back and forth in an arc. And because of that, I had to slot the end of the piece right here onto that pin. But that's not the way the mechanism would work on an actual shaper, because this would not be strong enough. This would probably break and it would be a weak point. So instead of using this little system right here, what they normally use is a link. And there would be a link. This would be cut off here, and a link that would be pinned here and pinned onto the ram, or it's probably going to be over on the other side. So that is the method of attaching the rocker arm onto the ram. Now if they don't do that, sometimes it is just pinned up here, not with a slot, but just pinned with a hole in the rocker arm, and there may be a little bit of a linkage on the bottom side. Move the camera just a little bit. They would need to have a linkage here. That allows movement up and down of the rocker arm. If it was fixed on both ends, it would bind immediately someplace in the stroke. I presently have this machine set for a stroke between these two black marks here, which is approximately not quite 6 inches. in order to change the length of the stroke on an actual shaper, the slide block is moved up and down, and there's usually graduations along there. At least there is on the Atlas and the RHODES. I'm not sure about other brands. But what I'm going to do here is I have a hole drilled and tapped into the gear. Actually, there are two holes, and I'm going to move this bolt from one hole to the other, which in effect is moving the slide block within this slot. So I'm going to do that off camera, and we'll see the difference in the length of the stroke. What I've actually just done is to shorten the length of the stroke. So look at the two pink markers now as I rotate it. So the stroke is shorter, and any shaper can be adjusted to almost an infinite number of different positions. On here, actually, I've drilled only two holes, so there are only two positions, but I have moved the point here, the pivot point here, closer to the center of the bull gear, and that gave me a shorter stroke. On any shaper, you can also change the position of the ram and the tool. In other words, do you want it here or do you want it here? And on a shaper, that's done with a binding post or a binding clamp at the top. But in the case of this teaching aid, I'm simply going to move the pin from one hole to another. Now you should be able to see that the position of the ram is totally different because I've moved this pin to this position from this position. So you can see how much farther the tool holder comes back. Too far, actually. Many of you know who Dave Gingrey is, and through Lindsay Books he had published a series of books on how to build a hand-operated shaper in your own shop. So there's many of those books that are out, and probably many of you have built those shapers, but actually right now I've got a hand-operated shaper, but I believe his is lever-operated, but yet it's an Armstrong, if you know what I mean. Well, I don't want to do very much cutting by hand, so I'm going to put the motor on it now. Now we are motor driven. And holding it at a constant speed, you should be able to see that the return motion is faster than the forward motion. Can you detect that? Almost sounds like a real shaper. Real fast on the return motion. Thank you, Joseph Whitworth. It is not the intent of this video to show you how to actually set up the work and machine your material on a shaper, but one point that I want to make here when adjusting the position of the tool and the work. You do not want to start it where the work is literally right up against the tool here and use a stroke that is very, very short. It's all right to have it pass up the work a little bit. This is longer than necessary so that the chips can clear before it starts to back off. However, at the beginning you probably want to leave about a ½ inch or so on there, because remember that the tool has stopped, and this has to accelerate a little bit. Now there are graphs of that you can look at in books, but the tool needs to accelerate and get up to its cutting speed. So you want to leave about a ½ inch there. So it'll work something like that. Also at the beginning you want that space so that the clapper box can come back down and get settled before it starts the next stroke. Wanted to make that clear. You know, old Tubalcain had contemplated making a series called How It Works, similar to one that is on TV, and this would have been an example of something that I would have done in that series. However, I'm presenting that as a standalone video in regards to that RHODES shaper that I really recently purchased, and there are videos on that. Make sure that you go ahead and watch those. But let me know if you're interested in videos how it works. Not electronic things though, or electrical things. It would have to be mechanical. You know, old tubalcain is interested in great men such as Joseph Whitworth, and I hope you are too, because I often mention inventors in my videos. I do not get many comments on from you people whether or not you care about that. But let me know if you like this type of demonstration, or am I spinning my wheels and wasting my time, because it was considerable effort to make the whole apparatus, so I hope you enjoyed it. And remember, this is what I started with, but even if there aren't many people out there that like this type of video, this building this really helped to clarify it in my mind exactly how this works, because just looking at the machine with that open cover in operation, which I showed you at the beginning of this video, it does not tell you very much. But perhaps some of your minds are a little more ingenious than mine and you can pick up what's happening. But I had to read a little bit about Joseph Whitworth and then do this, and now I really know what's happening here, and enjoyed this. I hope you did too. And this is tubalcain saying so long for now, and I'll see you in the next video.